Hello, Uggies Worldwide. I'm Dave Casler, amateur radio call sign KE0OG, here with another episode of Ask Dave. And today we're going to talk about radio frequency interference between your mobile rig and the car. And yes, it's a problem these days. You know, if you think about an automobile these days, it consists of three things: tires, an engine, and computers. The industry has kind of fixed it so that they make multiple computers per car. So there's like one that handles the fuel, one that handles the steering, and so on. Steering assist, I should say. You can still get it to the side of the road if your engine fails. But the thing is that all of these computers are generally pretty well shielded against interference, okay? So if you're in something like a Ford truck and you put a mobile antenna on top, okay, you're going to be able to operate pretty much any way you want. Now, if you had a Toyota Prius, well, first of all, a Prius, I'm not sure, has a metal roof, but their instruction manual says don't use two-way radios in that environment. Now, my experience is if 5 watts was okay, you know, but I wouldn't put out 100 watts. You can buy mobile radios these days that'll put out 80 watts. My question is, why? Because you're limited to line of sight, and 5 to 20 watts will get you there, okay? Any more is wasted because it just goes up into outer space, skims along the surface of the earth, keeps going in a straight line, okay? Yes, I recognize that the radio horizon is about 4/3 the visual. The point is, keep the power down when you're operating mobile. Also, you create a hazard for other people around you. And even though you're protected by that metal roof, there's still RF that comes in the windshield and so on. Now, what's the real problem with using mobile radios in modern cars? The answer is quite simply that your car has about 100 miles of wire in there, and each one of those wires is an antenna. They will respond to different frequencies. This question came from Don, Victor Alpha 3, Delta Delta November. He was concerned with it. He said that he was having problems with 40 meters. Okay, 40 meters, a quarter wavelength through that is 10 meters. If you have a wire that kind of goes back and sort of loops around in your car somewhere in the wiring harness, that could be a nice little quarter wave antenna for 40 meters. So if you put too much power out there, it will overcome the inbuilt filters and so on that are put in there to keep your car operating very well, even when, like, you drive by radio stations, antennas or something like that, where you get in a high RF field, or if, like, you're being bombarded with a radar sitting on the lap of a very watchful highway patrolman, that shouldn't stop the car either. Actually, today's cars are pretty good about withstanding radiation and all that sort of stuff like that. There is a common misconception that a high altitude electromagnetic pulse will kill all the cars. That's not true anymore. It might have been at one time, but they put a lot of stuff in there because the last thing they want is to have trouble with those computers. If you have to replace a computer, even a small one, it's a bloody fortune. So customers don't like that. They don't want these things to fail, so they're built pretty sturdy. So if you're going to put a mobile and you're going HF mobile, get that antenna up and outside, and I would cut the power back to like 50 watts or something like that. Now, I have a friend, he would go to parks and operate because he couldn't operate where he lived. So he'd sit in the parking lot in the community park, whatever it was, you know, watching the kids on the swings and all that sort of thing. And he would transmit 500 watts through a compromise antenna. Now, the reason for the compromise antenna was because it was mobile. So between the 500 watt uplift and the downlift of a compromise antenna, he was able to talk to people fairly regularly from his mobile setup. Now, that would be an older vehicle that you would do that in. I wouldn't recommend that on something like a Prius or a Miata or some of these little cars like that. The truck may be able to handle it. Now beware, if you blow out a computer in your car, it won't be covered by warranty, because they'll look at the computer and go, my goodness, what were you doing? Were you transmitting a very strong signal? So, big truck. Okay, maybe you can go 100 watts to an antenna that's mounted at back or up above or something like that. Yaesu makes a series of antennas called ATAS, A-T-A-S, designed to do HF in environments like this. And there's all kinds of things you can do with remote tuners and stuff to make sure that these things work. So if you're going to do VHF, keep it down. Now VHF has got a shorter wavelength, so more of the wires inside the car will respond to signals at that wavelength and will be putting quite a bit of power into those computers. Might even pop a fuse or something like that. So you want to be careful. The one thing you do not want to go down is your ignition computer, because the car will not drive at all without that computer. Okay, so I think that just gives you an idea of what's going on. The basic problem is that as you go up in frequency, you've got more wires in that wiring harness that can pick up a pretty strong signal. Normally an antenna will not pick up signals it's not tuned for. 40 meters is common. Just, he asks, why is it happening to him so much on 40 meters? Is simply because fundamental overload. Move the antenna to a different spot on the car or something. Use a truck, the metal roof. You've got this Faraday cage for all your wiring. A lot of cars today are made with plastic or glass roofs. Not very good for mounting spot for an antenna. So there you have it. Until we next meet, 73.